Hi class, welcome back to our lesson video for Unit 7, Lesson 2. In this video, we're going to continue talking about quadratic functions by looking at their rates of change. Basically, as we've done with most of our Algebra 1 work this semester, we're going to look at the pattern that shows up in quadratic functions. So let's go back to looking at a sequence and identifying and describing it as a pattern. Recall that the rate of change is describing the pattern of change or how we are changing from each term in the sequence. When we dealt with linear functions, we saw a pattern that was constant. This change stayed the same. In this sequence here that I'm starting off with, we have 2, 4, 6, 8, 10. That pattern increases or changes the same way each time. We're consistently adding 2. And so we would describe that as a constant rate of change that's staying the same. We've also described that as a common difference or as the slope of our linear function. And it created that line in our graph. In exponential functions, we notice that the increase or the change was changing. So if you look at this particular part of my table where I'm showing how the sequence is changing, my 2, 4, 8, 16, 32 did not have a change that stayed the same. First, the change was adding 2. Then the change was adding 4, then the change was adding 8, and then the change was adding 16. What we're able to see in this particular one is that our change is increasing, or the increase here was increasing. We also take note that that change was happening proportionally. As you go from 2 to 4 to 6 to 16, we can see that that change kept increasing each time. This particular one gave us our common ratio that ends up showing up as a pattern of multiplication. So our times 2 times 2 times 2 times 2 was a rate of change that was increasing proportionally. Now let's look at the rate of change that would happen in a quadratic scenario. To look at a quadratic scenario, I want you to go to our pacing guide and click on this Desmos activity called Revisiting Visual Patterns. As we click on this particular activity, I want us to go and look at a certain pattern that shows up. So look at this particular pattern on the screen. Here we have stage 1 had 3 tiles. Stage 2 now has, what is this, 6 tiles? And stage 4 has, what is this? 11 tiles. To create the next stage in this particular pattern, I notice a pattern that shows up to where we have a single block in the middle, or a square in the middle, with a tile on both sides. But then that square gets bigger. So like here, my square is 2 by 2, but then I still have 2 tiles on the outside. Here, my square in the middle is 3 by 3, but I still have 2 tiles on the outside. So I'm expecting that for stage 4, I would need to create a 4 by 4 square. So I'm going to click on these tiles here. Make 4 rows of 4 tiles, but then I'm going to put in extra tile on each side. I still have those additional 2 tiles. Let's check my work. And that's exactly what stage 4 looks like. As I start to now play around with this particular scenario, what I'm noticing is a pattern that shows up in how I was creating this. So for the stage number, let me turn this into a table because that is always a great way to organize our information. For stage 1, we saw that I had this 1 by 1 square, but then I had 2 additional tiles on each side. For stage 2, I had a 2 by 2 square, followed by 2 additional tiles on both sides. For stage 3, I had a 3 by 3 square in the middle with 2 extra tiles. And then for stage 4, I did a 4 by 4 square in the middle, followed by 2 additional tiles. This starts to create for me the sequence of 3 tiles, followed by 6 tiles, then 11 tiles. And then in stage 4, we had, what would this be? 16 plus 2 is 18 tiles. Let's look at the change that happened here. From 3 to 6 is an increase of 3. But from 6 to 11, we have an increase of 5. Then we have an increase of, sorry, let me put it on this side. So first we had an increase of 3, then an increase of 5. And now from 11 to 18, we have an increase of 7. Do you notice anything about this change? It's not the same. It's changing each time. But notice how it's consistently changing. This change each time is increasing by 2. So now what would happen in stage 5? If I had stage 5, then my tile picture would look like a 5 by 5 square. So let me get 1, 2, 3, 4, 5. Let me make 5 rows of that. So I'm just making some tiles with my highlighter. Okay, I'm on the 4th row and then now the 5th row. And then I would still have the 2 additional tiles that are on the outside. To me, it kind of looks like the shape of a hat. So now for stage 5, I've got a 5 by 5 plus 2. That's 25 plus 2, which is 27. Wow. Okay. 27, 18 to 27 would be an increase of 9. And look at that. That continues that pattern of the change increasing by 2. So if I want to continue this now, and let's say I want to create stage 6 without actually having to draw out all of these tiles, well, I'm thinking that I would just be able to say, okay, well, 2 more from 9 would be 11. So I need to increase by 11 this time, because that would be giving me this increase of 2 on the increase. So let's see, 27 plus 11 would be 38. I can even do that again. Let's do stage 7 now. This time, I would be adding 2 more to 11. So my increase would be by 13 this time. So 38 plus 13 gives me 51. So what we're seeing here now is that our change is still increasing, but it's not increasing proportionally. It's not my change keeps getting bigger through this idea of multiplication. What we notice in quadratics is that quadratics have a constant second difference. So this part of my table right here, where we see this pattern of increase the pattern by 2, this is what we're now going to refer to as a constant second difference. So throughout this Algebra 1 course, we have focused on patterns, and we've now described 3 types of pattern. There's a pattern for linear functions, There's a pattern for exponential functions, and there's a pattern now for quadratic functions. Our new pattern now is this idea of, if you notice the increase is consistently increasing, giving you a second difference that is constant, then that is a way to identify now what will be our quadratic pattern. So you're going to practice this today on a formative assignment. Our formative assignment is going to have multiple scenarios to where it's, here's a table, calculate the first difference, and then calculate the second difference as needed. If you notice that the second difference is the same for each one of these rows in this table, then you can identify that, yes, this indeed is a quadratic function. All right, I'll see you in the next video. Bye.